All right, now I can hear you. Should we wait a couple minutes, or has this been about how many people have been showing up for the other workshops?
It really depends. And they come up along the way, so yeah,
Okay,
about
I should
about
just get into
10.
it.
Yeah,
Or
sure. I
is that,
mean, you can wait 1 minute if you want. I mean, it's really up
yeah,
to
let's
you.
get a minute. How have the workshops been going this morning? I guess you guys are in CET, right? So you've had a couple hours already.
ET?
Do you use Central European time, or
Oh,
I
oh,
just
CET,
your
CET. I didn't hear.
the workshops have been going on for like 4 hours at this point.
Yeah.
Yeah, so I'd understand if you guys are a little tuckered out, but has it been a good day overall?
Yeah, great. What about you?
Well, I've had like 1 hour of, back and forth with the team on different things. But yeah, I had a great weekend, 4th of July. Like I was with my kids all day on the beach
Yeah,
uh,
great.
for
Yeah,
2 days. All
that's
right,
cool.
let's start. Let's start.
Yeah, let's start.
Let's see. Simon, Victory, Krati. Good. All right, so let me tell you about Uqbar. Uqbar is my company. I'm one of the co-founders, and I'm also the director of technical outreach and marketing. And we are building a ZK rollup, which uses the Cairo technology from Starkware, and we're also entering a closer relationship with Starkware, which will ultimately see our rollup as one of the first to be implemented as a level 3 network instead of an L2. So that's interesting to a lot of people, just because we're all curious, like, what does L3 mean in practice? And in describing the purpose of Uqbar and also how it works and what sorts of benefits we expect to get from the L3 architecture implementation, that might answer some general questions, not just about what Uqbar does and what the purpose of having generalizable ZK verification of non-Cairo languages is, but also what other things you might be able to do with Starkware's L3 architecture. So to begin with, uh, Uqbar uses at its core an operating system that is called Urbit. Urbit is a peer-to-peer operating system. It runs in a virtual machine, and but it's not just a metaphor for an operating system. It has a kernel. It boots up. You feed it in your private key, and then and it has an identity. Each node has a specific slot in the public key infrastructure of the entire peer-to-peer network, and all of the computations that it does are run by a simple language called knock, which is essentially a 12 opcode combinator logic. If you are technical, then you would know that there's a very, very small number of opcodes for a Turing complete language. And if you implemented those computations naively, it'd take a very long time to do even something very simple like, say, addition and subtraction using that. But you are um, you're able to optimize by taking out whole chunks of the code that is written in that small 12 opcode language and replace it wholesale with an optimization. Normally, it's an optimization that's written in C. A few of them are written in Haskell. And the beautiful thing about that is that the overall logic of how your programs work in Urbit is very, very simple. So you can reason about it easily. You as a programmer, I'm sure, have been in smaller projects and bigger projects, and you've probably noticed that in the smaller projects, you always know how all the different moving parts are working together. And in the bigger projects, it starts to become something that escapes the scale of human comprehension, and you just understand you're one tiny little part of the code, and the lead dev or the chief of product or whatever is really, really struggling at any given point in time to make sense of how all of these different pieces are working together. The underlying logic of having that optimized um, replacement of the simple opcodes with the different shortcuts is, even though in the end it ends up functioning like about 100 extra opcodes, because you know that all of those computations need to adhere to the same logic of the shorter opcodes. You know, if they crash, if the short opcodes crash, the longer set would also crash. And that allows you to reason about what your program does. It also has some other um, interesting advantages when you get to the point of wanting to do ZK verification. And what we're doing at Uqbar is we're writing one Cairo program called Zoc, and all that it does is it takes these Urbit programs and it runs them through Cairo, and whatever the output of the Urbit computation would be for Urbit, for those 12 opcodes plus the optimizations, it spits out a ZK proof of the same computation. So you could think of it as a little bit like using Cairo as a compiler. And what's interesting about that is that a lot of people are trying to build dApps and complicated smart contract protocols, and it involves a lot of different moving parts. It ends up needing a lot of infrastructure, and so as a result, you have then another like around the core dApps and protocols that are consumer facing. You have a lot of middleware projects where people are building infrastructure for other dApp devs to build. And what does that involve? It involves things like having an identity infrastructure. It involves having, um, you know, finding ways to make it simpler for people to code and program without getting lost. It involves setting up peer-to-peer messaging protocols between different nodes, different users of the service. It involves things like addressing to make it easy to find data. It involves different ways to implement and query databases, because if you really want to have stable communication between all these users, they need to start structuring their information like a database. All of that comes out of the box in Urbit. So if you build like the business logic of any app in Urbit, what comes out the other side has all of that infrastructure already built in before you even have your first user. And it has a lot of advantages, because even like very simple things like, I want to produce a dApp, but I'm going to upgrade it over time as the technology improves, and I need a way to reliably get peer-to-peer served, like decentralized upgrades to the next version of the software and the next version after that, without breaking the entire network of users who are playing my game, or whatever as the case may be. The ability to have all of that out of the box is why we are so optimistic about the prospect of using Urbit as essentially an execution layer for dApp developers. And the other side of that equation, that we need to have a lot of infrastructure out of the box to make it easy to develop these projects, but we also need to make it possible for dApps to use a lot of transactions very efficiently. If you're in Matchbox, I think you already know that ZK verification technology is probably the way to go about that. This is what we believe at Uqbar at any rate. It's, I think, a shared premise for a lot of the people who are going to be in this workshop. And that is why we implemented it in Cairo. And again, we have a single Cairo program, which allows us to have a lot of the advantages of Starkware's technology, but it allows us to move around a lot of the problems that arise when you have like a sprawling, ambitious project that you want to do that has to be implemented in Cairo, and everything is implemented at a very low level. It's implemented with registers. You're always getting your local variables revoked. You're always trying to figure out exactly how the slightly underdocumented Cairo code is meant to handle edge cases. And it's a lot of fun, but it's hard to make it scale for bigger projects, and it's hard to audit it. Obviously, Starkware provides incredible support for all of their projects to get feedback, code reviews, auditing. However, it's an advantage from our point of view that we're able to do one Cairo program and then arbitrary Urbit programs in a much simpler kind of higher level code, we'll all be able to compile to a ZK proof without any further development in Cairo at all. And that's not all. Starkware has been very, very supportive of us from the first that they heard of this project. And in the last month, 2 months, we've been having closer and closer conversations about the possibility of having Uqbar implement this not as an L2 rollup, but as an L3 rollup, or, you know, the exact numbers aren't exactly important. It could be an L2.5 to the extent that data availability gets settled down to Ethereum, but all the transactions get settled to the Starknet L2. But the bottom line is that Starkware has started to advertise the fact that they have nearly in production new technology for recursive proofs. And a recursive proof is one where the verification of the first ZK proof you've done is itself a ZK proof. It's a ZK proof of the verification of a ZK proof. So then you have a second verification, which checks the proof that the second level of proof that you just did. And the beautiful thing about that, if you're familiar with how Cairo programming works, you can use a ton of built-ins, that is to say, side gates, polynomial constraints on the ZK proving process. You can use a ton of them at the first level in the L3 proof, and then those add length to the proof. They add length to the verification of the proof at the L2, but then at verifying the proof of the verification, all of those, the extra computational overhead from those built-ins drops out, because the recursive level of proof doesn't need to resolve that. So I'll stop there for just a few minutes. Does anyone have any questions about that? Because that is it's a substantial advantage of the L3 architecture, and for some of you, that might be the most important thing that you take away from this talk. So I want to make sure if anyone has questions that I answer those. No? Okay. Then I'll go straight on. Now, what is required in order to be able to write a program that will run on Urbit and that Uqbar can then essentially compile to a ZK proof? And the answer to that is it needs to be written in a language that we call Hoon, which is most comparable probably to C, although many people who look at it think that it looks and like some of the underlying ideas are a little bit like Lisp, but it's not really exactly like either of those. It's a higher level language. It is, it's functional, it's weakly typed. If you think that those are useful advantages, which many people do, you'll have those advantages. And in fact, a lot of things in the system can be done just by using the type system. I have heard. I haven't, you know, used it very aggressively in order to get things done. I think it's better to, you know, set it up to receive exactly what you expect it to. But if you want to use the type system aggressively, you can. But it looks a little bit different. It has this clever idea for people who are very visually minded, but it seems more irritating to people who are really, really verbally minded, that some of the keywords use non-alphanumeric characters. That is to say, there's all of the different functions are classified 8 ways, and then each of those in each of those categories there are, you know, 4 to 8 key primitive functions, and essentially like keywords. A lot of the code uses 2 non-alphanumeric characters, like for example, a percent sign and a period would mean something to a Hundev, and they could also write it out in words. But you know, if you look at a lot of the code base in GitHub for different Hun apps, you'll see that it does have this very compact flow where people learn to recognize what the shortcuts mean, and they like to write it like that because then it's very easy to take in a glance, and you end up with programs that are very, very short, and become very, very easy for other people to do code reviews on, and also very easy to become interoperable. In other words, once you write one app, to use a real example, there's an app called Pals, where all you do in the Pals app is you say, these other users on the network are my friends. This is the nickname that I know them by. These are some notes that I want to have about them. And then other people can use that app and start to use the data in it to do things like create rumor mill apps where you can pass out an anonymous rumor that will only go to your friends and their friends. So it's that sort of thing. Um, and we plan in the future. I know that there's currently a Matchbox hackathon going on, and there was a little bit of timing miscommunication, and we would actually be happy to go into detail about what kinds of things we need in the our Cairo repository. In fact, I can paste our repository in right now. But we hope to have a longer series of workshops in the coming month to month and a half with Matchbox to teach you guys really in detail, if you're interested, how this works. However, if you wanted to start doing something interesting in Cairo without learning any further language, you can look at Zoc and see what we've got going there. And the main things that we have to do on this going forward are we're very, very interested in turning a lot of the functions in that program into custom built-ins, which we're still figuring out how we want to do. But if you think that that's something that you are an expert at, we would love to see you play around with that, and we would love to give you any sort of support that you want with that. If you want to look into the folder for what are called JETs, that is to say the just-in-time optimizations, we would love to give you whatever advice you need in order to continue to add more and more of those optimizations that make the code fast and performant. But we're also happy just to have you look at it and talk about it. And there's some things in there that may be interesting. We were the first ones to pioneer back in April, I believe, the concept of using a switch function for control flow in Cairo programs rather than using an if-else, if-else, if-else chain, which at that point was very common. I don't know whether other people have started to adopt using switch functions like we do yet. When we added that, we found that it improved our step count on our programs by a factor of like 5. So not quite an order of magnitude improvement, but pretty good. And there's some other interesting features in there that Phil, our lead Cairo dev, has put in that we would be happy to talk about if they interest you. So I think that is good as an overview of what we're doing. And I should also say, because we're not trying to do anything fancy with how we implement our rollup, but it's worthwhile to go over the basics, that it's going to be sharded, that we call the shards towns. Each town is going to have a sequencer assigned who will do the kinds of sequencing things that you're familiar with from other ZK rollups, and essentially produce a bundle of transactions to execute that then get fed into a ZK proof, and the ZK proofs can be combined in various ways, but ultimately they you need to bundle a lot of transactions together and then give them to the the builder who's going to make a block and prove it, and then send it down to Starknet. The Starknet, the ZK rollup Starknet contract on Starknet is another thing which we have not. It's going to be a fun and interesting Cairo undertaking that we haven't started yet because we just reached, we've just been reaching agreement with Starkware about this recently, and we had done some preliminary research on what we wanted our Solidity ZK rollup contract to look like, but we haven't begun to think about, like in detail, what the Cairo ZK rollup contract will look like. And once we've worked a little bit more on what Zoc is going to look like with Starkware, we think that they will probably have some interesting advice for us, because there are also other big advantages that I haven't stressed here to the L3 architecture, including the claim that you can get composability of transactions and liquidity with other L3s. I'm not 100% sure how that will work and whether it's something that we want to stress as a major advantage of using Uqbar, because obviously it's going to depend a lot on how performant that kind of composability is at the point when we're in production. By the way, we are going to have a live testnet with live developer tools before September 22nd, which is when there's a big Urbit convention in Miami. So that will probably be early September that we'll be able to roll out the red carpet and invite on anyone who actually wants to have live, like deploy live on the testnet any sort of contract or DApp logic that they want to work. And sometime in the middle of 2023, I don't want to commit to any particular date, but let's say to be on the safe side, certainly by the end of 2023, we hope that Uqbar will be live, and any ZK apps that you want to be running on our network instead of directly on StarkNet will be ready. And I think that that's going to be particularly interesting to people who have very ambitious plans for what they want to do with their ZK games, just because the advantages of being able to work in a higher level language become more weighty as you are talking about larger games, more ambitious computations, more ambitious interactions between the different modules of the game, larger teams who need to, have a whole, like basically if you have a project manager on your ZK game, you want to be writing it as an Urbit app and not writing it directly in Cairo. That would be my guess. If you can do it by yourself, then it's much more manageable, although you still might be able to squeeze more out of Uqbar and writing the logic directly in a weakly typed functional language where you get all of this infrastructure for free and don't need to code it yourself. Well, that's Uqbar. Any questions?
Hey, if there are no questions, then I'd just like to say thank you for this workshop. It's really fascinating stuff you guys are working on. I can't wait to see where all of this is going, especially if all of the layer 3 stuff and the potential for composability, as you mentioned, between different layer 3s and things like that. That's really going to be super interesting. In terms of this hackathon, I would like to ask you, do you maybe have some kind of top secret tip for people that are just starting out with Cairo, or any kind of words you would like to share to give on the way?
That's a very interesting question. I would say personally, I think that reading the white paper very, very carefully helps if you're just starting out. And also, I would say that more so than with, say, if you were learning C or Python or some language like that, in Cairo, sometimes if it doesn't seem to be working out the way that you expect it to when you're trying to do something that's a little bit different and a little bit difficult, sometimes if you just try a few slightly different things to see what works, even if it doesn't fully seem like it should work, Cairo does reward experimentation to some extent. It is the experience that we've had.
Awesome, thank you. I think that can help a bit to put things into context. Are there any questions for Hockman and about Uqbar and Urbit?
One quick question on my end. So first of all, awesome talk. Thank you. That was super informative. More broadly, so when you were talking about using Cairo as a compiler, that was pretty mind blowing. Do you see that kind of being the general direction for ZK based layer 2s that use Cairo is using that as kind of a lower level compiler language and eventually building like higher level languages on top of that?
Thank you, Simon. That's really an excellent question. And I think that the answer is It depends. The technology is moving so rapidly. You know, a year ago when we were starting Uqbar, we certainly wanted to have ZK verification as the ultimate direction of our roadmap, but we realized within a very few months that it had improved an enormous amount from the research that we had done, even in winter 2020, 2021, right? Starkware had come an enormous way. Cairo had come an enormous way. There was also briefly another competitor language to Cairo from ZK Sync that I think didn't do as well, and so they deprecated it and hid it, and took the documents off the internet. But a lot of people are making very rapid progress. I think that there's you've probably also heard that very quickly several networks, including the granddaddy ZKL1 Zcash, they've moved to Plonks. There are several new projects, including, let's see, Risk Zero, Lurklang, Heliax, just to name a few. I'm sure there are many others that I haven't heard of that are like they're building like fully novel ZK circuits. And what I think is that it's going to depend a lot on the performance, first of all, of Cairo Starks, secondly, of the L3 architecture, specifically how it works with the how effective the recursive proofs are at allowing people to use built-ins efficiently, how well it works with what I refer to as maybe a 2.5 architecture, where you can still inherit directly the guarantees of data availability from Ethereum L1 without compromising on getting the efficiency advantages of being layered on top of StarkNet. It's also going to depend on the composability thing you mentioned. Like, that's very exotic. That would be very powerful if it works in the most extensive sense that you can imagine. What I think is that in the end, there are huge advantages to using a higher level language. And if all of the performance advantages of the L3 architecture that Abihu and Uri are hoping to be able to deliver come through, then I don't think that Uqbar is going to be the only ZK rollup to approach this as an L3 on top of StarkNet. I think that there will probably be others that we're going to have to compete with eventually. I think there are a lot of advantages. I think that if the advantages that that the L3 architecture delivers are not as large, then it's possible that a lot of use cases are going to need to use StarkNet directly and have all of their contracts and computations done directly in Cairo in order to, squeeze out just that extra little bit of performance that comes from avoiding the compilation step. Does that make sense?
Yeah, that's super helpful. Thank you.
All right, do we have
any other questions? I think we have time for one more quick question, and then we are at the end of our time. Although I'm happy to stay here for anyone who is curious, but I believe that Eli and Spikemus and a few others will probably need to move on to the next workshop.
No worries. If anybody wants to show up, just feel free to do.
If there's no one else, thank you very much, Eli, and thank you, Matchbox. This has been a pleasure.
Thanks to you, Aquin. Very cool, very nice, and let's keep in touch for further workshops.
Yes, indeed. All right, bye guys. Have good luck in the hackathon.
Thank you.
Thank you. Have a great day.
Bye.